Welcome to my video on matrix multiplication. In this video, I want to do a couple of examples and go over just some of the basics on matrix multiplication. Okay, these three boxes here represent our just three matrices. This is going to be our A matrix, our B matrix, and these are going to be filled with numbers or equations in the boxes. And what we know is this is an M by N matrix right here. It has M rows and N columns. So that's that matrix. Now the second matrix is going to have N rows and P columns. So it's N by P. And for this to be defined, the two N's have to be equal. And if they're not, then it just won't work. It's undefined. And then your final resultant is going to be an M by P matrix, which is going to be this matrix here. And when we're going to do our additions, our multiplication, basically we're going to take the first row times the first column. That's going to give us this first element right here. And if we want to take the second row times the first column again, that'll give us that element. And on, row times column, that element. Then finally, we start doing in the second column, take the first row times this column, it's going to give us that element. So that's what we're going to do. We'll do a couple examples where we go through this and just verify, explain what this is and how it works. In this example, we want to take the matrix 4, 1, 2, 8, and multiply it by 3, 5. Okay, this is going to be a matrix times a vector. When we have a matrix that's like a 3 by 1 or a 1 by 3 or 1 by 2 or 2 by 1, in this case we've got a 2 by 2 and it's a 2 by 1. So this one is going to be our vector basically, and these words can be used interchangeably. A matrix that is a kind of one-dimensional either row or column vector, we call those matrices due to their relationships to physics and how we can treat them in a three-dimensional or a Cartesian coordinate system. So let's look at this matrix here. First of all, do these agree? Do these numbers agree? Yes, they do. So we can do it. It is defined. And then out of this, we're going to get a 2 by 1. So our result is a 2 by 1. So the first thing we want to do, let's take our first row times this column, and let's see what we get here. That's going to be equal to 4 times 3 plus 4 times 3 plus 2 times 5. So there's our first element. Now to get our second element, so we're going to have 2 rows and 1 column is what we're going to have. So this is going to be row 2 times that same column again to get our second element. So that's going to be 1 times 3 plus 8 times 5. Now, if I want to complete the multiplications and additions to get our 2 by 1 matrix, what we're going to do is we're going to take the 4 times 3, so that's going to be 12 plus 10, and the second element is going to be 3 plus 40, so that's going to be 2243. So that is going to be the result, and that is a 2 by 1 matrix. So that worked. In this example, we want to do a matrix and do it both ways. What we've got here is we've got a column and row vector. So we've got 3, 6, 1 times 1, 2, 4. Okay, so this is going to be a 1 by 3, 1 row, 3 columns. This is going to be a 3 by 1. Now these are the same, so that's good. Our result is a 1 by 1. So we're going to get out a 1 by 1 matrix. This is probably the simplest case. So what we're going to do is we're just going to multiply this row times this column and sum it all up. So we've got 3 times 1 plus 6 times 2 plus 1 times 4. That's going to be equal to 3, 12, 4 plus and that is going to be 15 plus 4 is 19. So we just get a 1 by 1 matrix out, and that is our answer. Now things are going to change drastically if we go the other direction. Let's do a 1, 2, 4, and this is why that matrix multiplication is not commutative. You'll see it just gives a very different answer. So here we've got a 3 by 1, 3 rows, 1 column. And here we've got 1 row, 3 columns. So out of that, these match. So it is defined. Multiplication is defined. And so we're going to get out a 3 by 3. So that's what we're looking for. Now, we've got to figure out exactly what we're going to multiply together. So we're going to take the first row times the first column, which is going to be that times that. So that's our first element. That's 1 times 3. Now we take our second row times the 1 times 6. So we're going to get a 1 times 6. We're doing the second element right here. And then the third column in the first row is going to be the 1 times 1. So that's going to be 1 times 1. Now we go to the second row and multiply all that out and do the same thing again, multiply each of these individually. So that's going to give us 2 times 3 is the element on the second row, first column, 2 times 6, and 2 times 1. Now going down to the final element here, the 4, then we multiply by the 3, 6, and the 1 again. So 4 times 3, 4 times 6, and 4 times 1. So let's see what this comes up with. 1 times 3 is 3, 6, 1, 6, 12, 2, 12, 24, and 4, multiplying that all out. So that is the result, and you can see we did get out a 3 by 3. So this clearly shows the order of multiplication is very important. I hope you got something out of this video and from a couple examples on matrix multiplication. And matrix multiplication is very tedious and can be complicated, so you just got to take your time and just go through it step by step. And then hopefully you won't make a mistake. But it's easy to make a mistake. Hope you got something out of this video. If you did, like it, subscribe to my channel. Thank you for watching.